Okay, so welcome. Today we're going to learn how to solve two-step equations. So make sure you put that title in your notebook. All right, so two-step equations. It takes 2 steps to solve an equation that has 2 operations. And so we're going to use PEMDAS backwards. So whenever you're solving these equations, you should only be doing 2 operations. And using PEMDAS backwards, that means you will first start with any addition or subtraction. That will be number 1. And then you'll undo any multiplication or division, and that will be step 2. So we're working backwards. Okay, first example here. 2x minus 15 equals 5. So working PEMDAS backwards, we have to undo this subtraction. So how do we undo subtracting 15? Well, by adding 15 to both sides. So plus 15 over here. And so negative 15 and positive 15 will balance each other out. You have 2x, and bring down your equal signs. And then we have 5 plus 15, and that's 20. And now we're going to undo this multiplication here because we're just to a one-step equation at this point. And so we have to divide by 2, divide by 2. And so we have that x is equal to 10. Next example here. 11n plus 1 equals 67. So we have to undo this addition first. So we will undo that with subtraction of 1. So minus 1 there. Positive 1, negative 1, cancel. You just have 11n equals, and 67 minus 1 is 66. Now we have to undo this multiplying by 11, so we're going to divide by 11 on both sides because we have to keep it balanced. So 11n divided by 11 is just going to be n, and that's equal to, and 66 divided by 11 is 6. So n is equal to 6. And with these, what you want to do is, take what you get for your variable, your solution, and plug it back in. So we'll do 11 times 6 and plus 1. And we're supposed to get that it's equal to 67. So 11 times 6, that's 66. And we have the plus 1 equals 67. Now 66 plus 1, that's 67. And so we end up with 67 equals 67. Is this a true statement? Yes. So our answer was correct. N is indeed 6. I would really suggest going back and checking your answers like this, especially when you have a negative sign on your variable, or you're dealing with negatives in any kind of way. So this example that we're going to do right now is a perfect time to do that. So we've got to get rid of this plus 4 with a negative 4. Or minus 4. You have to get used to thinking of that subtraction sign and minus sign or negative sign in both ways. So it depends upon the context, as I like to say, is whether you read it as subtraction or as a negative sign. So positive 4, negative 4, cancel. Then we have 8 minus 4. It's going to be 4. And all we have left over here is that negative 2y. Now here, we want to get rid of everything that's in front of that variable, this whole coefficient. Sometimes y'all will divide by 2 and forget to divide by negative 2, because if you forget to divide by that negative, you're going to end up with negative y. And so this is why it's really important that you go back and check your work like I showed you on the previous problem. So divide by negative 2, divide by negative 2. So negative 2y divided by negative 2 is just going to be positive y. And 4 divided by negative 2 is going to be negative 2. And so we'll go back and plug that in. Negative 2. And then in place of y, we're going to put negative 2. And then plus 4. And we should get that it's 8. So negative 2 times a negative 2 is going to give us a positive 4. And then plus 4. 4 plus 4 is 8. 8 is equal to 8. We are good. So then, maybe you had made the mistake and you forgot to divide by negative 2, and you just divided by 2. And if you had done that, then you would have gotten that y is positive 2, which when you would have plugged it in on this side here, you would have gotten negative 2 times a positive 2, which would be a negative 4. And a negative 4 plus a positive 4 would have given you 0. And 0 is not equal to 8. So you would have known that you made a mistake somewhere. So always go back and check your work, especially when you've got negatives. Okay, next example here. 5x minus 2 equals 3. Get rid of this subtraction first with addition. So plus 2. So you have 5x equals, and 3 plus 2 is 5. We've got to get rid of the 5 in the front, so divide by 5. Divide by 5. 5x divided by 5, just going to give you x, and 5 divided by 5 is 1. So x is equal to 1. So again, notice we're undoing any addition or subtraction first, and then we're undoing any division or multiplication next. So working PEMDAS backwards. Okay, we have x divided by 5 minus 9 equals negative 2. So let's get rid of this minus 9 with a plus 9. Those will cancel. We have x divided by 5 is equal to, now we have 9 positives and 2 negatives. That's going to give us 7 positives because we have different signs, so you subtract. So now we have x divided by 5 is equal to 7. Well, we'll just undo that dividing by 5 by multiplying by 5 on both sides. And you want to be very careful when you're showing your multiplication. Make sure you show it up in the numerator area, because if you're showing it down below, it kind of gets a little messy. So those cancel. X is equal to 35. All right, now we'll do this one. Bobby bought 3 t-shirts at the mall and a pair of pants for $16 at the clothing store. Altogether, he spent $28 for the clothes. How much was each shirt? Write an equation and then solve. Okay, so our equation is going to take the form of the items purchased, times their price is equal to the total price. So we've got that he spent altogether $28. And then it says he bought 3 t-shirts at the mall and a pair of pants for $16. So we know the pants are 16, and that was bought together with, so plus 3 t-shirts. We don't know how much the t-shirts were a piece. So we're just going to say 3, let's just say, we'll just call it Y, Again, we don't really want to use S for shirts because it can look like a 5. You don't want to necessarily use T unless you're really careful with writing it, because that could look like a plus sign. So now we'll go on ahead and we'll get to solving it. So you've got to undo this plus 16 with minus 16. Okay. So 3y equals, and 8 minus 6 is going to be 2, and 2 minus 1 is 1. So 3y is equal to 12. So the 3 shirts together cost him $12. So divide by 3, divide by 3. The shirt is going to be $4. So each shirt was $4. Okay. Diane sold 9 flowers that cost the same amount each, plus a dozen roses for $28. Altogether, she sold $73 in flowers. How much was each decorated flower? So those are those 9 flowers up there. So we have the 9 decorated flowers that cost the same amount. We don't know how much they cost, so we're going to say 9 F for flowers. And then plus, because it says plus, a dozen roses for 28, so plus 28. And that was equal to a total of $73. So we have 9F, and we really don't need this like that. Let me get my eraser here. Oh well. So we're going to get rid of this minus 28. All right. Well, it seems like our technology is quit working for today. So we're going to go on ahead. I'm going to let you guys figure out the solution for this, and then we'll check it in class. So see you tomorrow. Bye.